In this lecture, I will discuss quantum numbers. After studying this lecture, you shall be able to know the concept of shell, subshell, and orbits. Understand the concept of quantum numbers and orbitals. Know the characteristics of principal quantum number, that is n, azimuthal quantum number, that is L, magnetic quantum number, that is M, and spin quantum number, that is S. What is shell? An orbit is a well-defined circular path in which electron revolves around the nucleus of an atom. Means electrons orbit the nucleus of an atom at different ranges called shells. Each shell has a different energy levels. Increasing further, it is from the nucleus. Each energy level is a given number called as principal quantum number, that is n. The closest shell has a value of n is equals to 1. The next shell has a value of n is 2 and so on. The maximum number of electrons possible in the first four energy levels are: if n equals to 1, that indicates the first shell having the maximum number of electrons is 2. If n is equals to 2, that indicates the second shell having the number of electrons is 8. If n is equals to 3, that indicates the third shell having maximum number of electrons accommodate in the shell is 18. And if the n is equals to 4, that indicates the fourth shell in which maximum number of electron is 32 and so on. So, there is a formula to calculate the maximum number of electrons that can occupy a shell is 2n raised to power 2. As we know, electrons are placed into available shells starting with the lowest energy level. Each shell must be full before the next starts to fill. This model breaks down at the n is equals to 3 shell because each shell has a subshell. Now we will discuss about what is subshell. A subshell is a subdivision of the electrons shells separated by the electrons orbitals. There are four subshells S, P, D and F. Each subshells can hold a different number of electrons. S, which is spherical in shape, having maximum number of electrons is 2. P, which is dumbbell in shape, having maximum number of electrons in this is 6. D, which is dumbbell shaped in structure, having maximum number of electron is 10. And F, which is complex in structure, having maximum number of electrons accommodate is 14. The number n determines how many of the subshells make up the shell. For example, the first shell is made up of one subshell, that is 1s, which contains total number of electron is 2. The second shell having two subdivisions or subshells, that is 2s and 2p, having the total number of electron is 8. The third shell having the three subdivisions, that is 3s, 3p and 3d, having the total number of electrons in this shell is 18. And the fourth shell having four subshells, that is 4s, 4p, 4d and 4f, having the total number of electrons in this shell is 32 and so on. The number before each subshell specifies which shell it belongs to. For example, lithium has 3 electrons. 2 will be first fill up in the first shell, that is 1s subshell. The remaining electron will appear in the second shell in the 2s subshell. Now, we will discuss quantum numbers and its characteristics. There are four types of quantum number, that is principal quantum number, orbital quantum number, magnetic quantum number, and spin quantum number, which is represented by the n, l, m, and s. The principal quantum number governs the electron's energy and average distance from the nucleus. The orbital quantum number L determines the magnitude of an atomic electron's angular momentum. The magnetic quantum number m specifies the direction of an atomic electron's angular momentum, and the spin quantum number s of an atomic electron has two possible values, that is plus half or minus half, depending on whether the electron's alignment itself along a magnetic field, that is plus half, or opposite to the field, that is minus half. What is orbitals? Orbital, it is a three-dimensional probability space around the nucleus of an atom where the possibility of finding the electron cloud is maximum, that is 95%. Orbitals are the regions in the space where electron is likely to be found, as 90% of the time the electron is within the boundaries described by the electron density map, and the exact path of an electron in a given orbital is not known. We use quantum number to describe orbitals. A given orbital can be described by a set of four quantum numbers, that is principal quantum number n, angular momentum quantum number L, magnetic quantum number m, and spin quantum number. Now, we will discuss all the quantum numbers in detail. First, we discuss principal quantum number n, which describe the size and energy of the orbitals, possible values whose number integer 1, 2, 3, and so on. As n increases, so does the size and energy of the orbital. Next is angular momentum quantum number, that is L. L is related to the shape of the orbitals. Possible value of L is an integer between 0 and n minus 1. Each value is also assigned a letter designation, that is S, P, D, and F. For example, if the value of L is 0, for that letter designation is S. When the value of L is 1, then the letter designation is P. Similarly, when the value of L is 2, for that letter designation is D. And if the value of L is 3, for that letter designation is F. This table describes the possible value of L and designation for a particular n value. If the value of n is 1, for that possible L value is 0 and the designation for that is 1s. If n is equals to 2, for that there are two possible L values, that is 0 and 1, and designation is 2s and 2p. When the n is equals to 3, there are three possible L values, that is 0, 1 and 2, having three designating letters, that is 3s, 3p and 3d. For n is equals to 4, there are 4 possible L values 0, 1, 2, 3 and 4 designated letters, that is 4s, 4p, 4d and 4f and so on. Now we will discuss magnetic quantum number, that is m. M is related to the orientation of the orbital in 3D space. Possible value of M is -1 to +1. For example, if we consider p orbital having the L value for this is 1 and thus the possible M values are -1, 0 and +1. Means these are 3 M values corresponding to the 3 possible orientation of the p orbital. This table describes the possible value of M and orbitals for a particular value of L. When the value of L is 0, then the possible value of M is also 0, which indicates by the 1 orbital. When the L value is 1, that shows p orbital having 3 possible values of m, that is -1, 0, 1, which indicates by the 3 orbitals. When the possible value of L is 2, that indicates d shell, then the possible value of m is -2, -1, 0, 1 and 2, which indicates by the 5 orbitals. And if the value of L is 3, having value of m is -3, -2, -1, 0, 1, 2, 3, which is indicated by the 7 orbitals. The last quantum number is spin quantum number S. A fourth quantum number was added to describe the spin on a given electron called electron spin quantum number, that is S, and the possible values of S is +12 and -12. Based on our presentation, now I will give you some practice questions, that is write a short notes on shell, subshell and orbitals. Discuss the characteristic features of the quantum number. Write down the short notes on principal quantum number and angular quantum number. Discuss the property of magnetic quantum number and define the term spin quantum number. These are the image sources which is used in our PPT. These are the references. Thank you.